Okay, we are going to go into section 2.6. If you notice, I did not hardly cover anything in 2. This is the only section we're covering in section 2.6. Section 2 or chapter 2 is all about proving something to be true. Okay, I am not going to go through all the different exact ways of proving things, but we will talk about how do you know something's true. Okay, the 2.6 is about 2 of the famous proofs that we've done. Okay, it's talking about 2 of the theorems that we use all the time. These 2 theorems are called, one is called the Pythagorean. Okay, it is basically that if you have a right triangle, okay, it has to be a right triangle. If the triangle is a right triangle, then, okay, the hypotenuse squared, which a lot of times is called, actually a lot of times it's called C, is equal to one side squared times the, or plus the other side squared. We write it like this: a squared plus b squared equals c squared. This is a side, or sometimes they call it the leg of the triangle. That means it's part of the right angle. Okay, this is the other side. The other side of the triangle, the leg. Okay, so it's the part, the legs actually form the right angle, is how we look at that. The C is called the hypotenuse. It is always the longest side, because the longest side is always across from the biggest angle. And in a right triangle, the biggest angle you're going to have is the 90 degrees. Okay, if it's a right triangle, the biggest one will always be the 90 degrees because it has to add up to 180, which we haven't gotten to that theorem yet, which is what we're going to come to. But that is what we have to come up with. So just knowing basically which is the hypotenuse, what are the legs? Well, they're the 2 shorter sides. You could also call them those. They're the 2 shorter sides than the longest. Okay. It doesn't matter which you identify as A or which one you identify as B. They can interchange. C cannot be interchanged. There's only one hypotenuse in your drawing. Okay. So what we're going to look at today is why this works. We're going to see if it actually works. We're going to make some triangles, and we're going to actually add up the areas and see if they equal on the triangles that we make. Okay. When we do that, are we proving that this statement is true? What do you guys think? If we do a bunch of different right triangles, if we look then at them and see that this works, are we actually proving that it's true? Micah?
I'm gonna say yes.
Okay, why?
Because, I guess you probably have to explain it.
Okay.
It'd be no, because you don't actually, and they don't give you C.
Oh, we know C. We can find
no.
C because we can measure it, right? Yeah.
It's proving it for the triangles that you've done, but you don't know if it works for the triangles that you haven't done.
That's correct. So when you do example problems, you've proved it for those cases, but you haven't generalized it to be true for all right angles. So it takes more to prove it than just to show. Okay, the interesting thing is to prove something, you have to make it sure it works for everyone. To disprove a statement, you only have to show it doesn't work for one. If it doesn't work for one, you've disproved the statement. But if you're trying to prove it, you have to be able to somehow generalize it all the way through and say, this works for all right triangles. Now, it has been proven, so it is a theorem. We will talk about how they proved it later. We're going to show how you can see it today, just because this is one of the most important theorems in when we're talking in geometry. It is also one of the most used theorems around in our culture. Okay, we use it all the time to make sure that things are at perfect right angles when you build stuff. They calculate that stuff. Okay, so that is something that they're always looking at. Okay, the second theorem, this is the first. The second famous theorem is called I don't know what it's called, triangle sum theorem. The triangle sum theorem. And this says if you have a triangle, then the sum of the measures of the angles equals 180 degrees. Okay, we use this all the time. This is one of those that we're going to use again and again and again and again. Okay. Okay, so the way I've written them are called conditional statements. Okay, notice, I just want you to know what a conditional statement is. I've written these as conditional statements. That means if something is true, then something else is true. Notice I wrote it if the triangle is a right triangle. So we have to first see, is it a right triangle? If it is, then we can say a squared plus b squared equals c squared. So that's a conditional statement. It must meet this condition that it's a right triangle. Okay? This says if you have a triangle. So the condition is it has to be a triangle. This doesn't work in anything else. Well, hence the triangle sum theorem, but doesn't work in anything else. If you have a triangle, then the sum of the measures of the angles equals 180 degrees. So if you measure all the angles, it equals 180 degrees. So they're called conditional statements. You have to meet the condition first before you can go and say the other is true. Okay, so basically this is the assumption they start with when they're proving it. They start with the fact that you have a triangle. Here's the condition that they start with when they start to prove it. They have a right triangle. Okay, so those are what they start with. Those are the assumptions you start with. And then they go on to prove this statement, and they can prove it in a generic way using variables. Then you can say it's absolutely true. Okay, because now we've got it for a generic form, and so that works for what we're looking at. We'll look at the actual proofs later. But today what I want you to do is we're going to spend some time just seeing how this works. Because I think it's good to see it, that it actually works. And because sometimes we go, oh, okay, well, big deal. Well, it's a big deal because these are very easy to use. And we use them a lot, and so it is a big deal. So what I'm gonna do is give every one of you a piece of graph paper. I don't have enough here. I have enough in my bag. Not every pair, let's see, we're gonna make a pair of 3. Okay, David, you wanna move over there?
Maybe
Let's,
just need that piece of graph paper.
yes, you just need a piece of graph paper.
Do
Well, you may
my own-
need 2.
I have my own graph paper.
Okay, you have your own graph paper, that works. So I'll give you one, and then take yours over with you. So, how about the 3 of you? Right? I'll give you a couple pieces of graph paper. Okay, Micah and Paxton, you're gonna work together today? Yeah, I'll give you a couple sheets.
That's my wrap.
And you guys are gonna get a couple sheets. Okay,
Is this for the notes?
no, this is, we're doing an activity now. Basically, the notes, we're just writing those down. I added some stuff, I added the conditional part of it, cause I didn't teach you that, that's not in there. So I put in the conditional part, that was the addition really that was from what you took notes on at home. Okay,